light of the impending self-isolation, what I thought I'd do is record a short video that explains the next and one of the last parts of the assignment we haven't covered so far, which is flowcharts. So for your assignment, you're going to have to provide and produce a flowchart of your game's main logic, which is the main points within the game. So normally it's sort of one for the main menu and one for the gameplay. So flowcharts are quite a common thing, and you've probably used them before. People use them all the way back in primary school. Okay. The main part is that we're now looking at formal flowchart logic. Okay? And formal flowchart logic is made up predominantly of three parts. It has a start and a finish, which is represented by this rounded rectangle. It has a process, so it has a case where you actually just have to do something, which is represented by the normal rectangle, and a decision, which is represented by the diamond. Those of you that are fans of Big Bang, Big Bang represents an algorithm really well in terms of the friendship algorithm. The clip to see it is free available on YouTube. But the basic premise is that Sheldon comes up with an algorithm to help people make friends. And it uses demotion notation, so the things are slightly different, but on the whole is perfectly fine. We start with placing a phone call. So we place a phone call and then we check to see if they're home. If they are home, we go to question. If they're not, we leave a message. And it can be followed through, and it checks and routes each option, each decision, and each process. So depending on the response to sharing a meal, if they say no, it moves on to hot beverages. If it says yes, they dine together and become their friendship. And in the episode, if you haven't seen it, Sheldon gets stuck on the right hand side in this loop, and one of the reasons why we actually use flowcharts is to actually trace things and try and trace things out, and then if we do find things like loops, we do find problems, we can correct them very quickly and very easily. So actually loops are one of the problems because you can get into a never-ending loop, which is what Sheldon gets stuck with. It's Sheldon, so he doesn't actually like any of the interests that are selected, so he keeps going round and round the loop, and he basically gets edited to find the least objectionable action. One of the key examples of algorithms, and a really common one, is for making a cup of tea. This is a key example because everybody is familiar with it. Almost everybody has either made a cup of tea themselves or seen somebody making one. And the premise is relatively simple. We start at the beginning with the idea of, is there any water in the kettle? If there's not, we fill it up and we then switch the kettle on. And you can see that they both lead either way to switching the kettle on. Then we put the tea bag in a cup. We check to see if the kettle boiled. If it's not, we keep checking. So only until that kettle boiled do we pour the water in the cup. And then we add milk. We check to see if the tea is light enough. If it's not, we add more milk. And if it is, we move on to pouring water in a cup. And then we end. The savvy of you, or the more experienced tea makers of you, might have realised that actually there's something wrong here, ignoring the fact that different people put milk in at different points and approach it in different ways. Many people like to have sugar or some sort of sweetener in their tea. So within the algorithm, what we should do is check to see if people want sugar or sweetener, and then incorporate that in. So pause the video, take a few minutes to think about where would you put the modification to the algorithm to include the sweetener or to include sugar. It doesn't really matter where you put it. I will show you one answer, but actually there are a few different ones. So this was my answer. So I changed the last box, the adding water, which isn't really needed. You know, we don't need to add any extra water. We can just pour all of our water in here. Okay. So I changed it, okay, and I added this bit here. Okay. So my first bit is the decision on, is the tea sweet enough? If it's not, okay, you add some sugar, okay, and then whatever you do, you always come back around. Okay. When it is sweet enough, we then end. Okay. The key here is that actually all we've done is replaced this termination box, okay? And we have our endpoints at different places. Okay? So we'll always check to see if the tea is sweet enough. If it's sweet enough without any sugar, then we can end straight away. Otherwise, we add sugar, and you could make the algorithm more and more complicated to add things like sweetener or even stuff like honey. So what I'd like you to do is I'd like you to draw a flowchart for a computer blackjack game. For those of you who aren't familiar, blackjack, or 21 as it's always known, is a really, really simple card game. The basic premise is that the dealer will deal you 2 cards. You'll look at those 2 cards and you'll decide if you want a extra card or not. Okay. And you'll do the same thing each turn. So each turn you look at your cards that you have in your hand, decide you want an extra card or not. The aim being to get to 21 or close to it as possible. If you go over 21, you bust. Okay. The key part here is I'd like you to remember that the main parts of the flowchart are the start and finish, the processes, and the decisions. It's really important that we use the correct information and the correct symbology. That correct information, that correct symbology really means that actually you understand flowcharts and enables you to have a clear and consistent viewpoint. There'll be an assignment uploaded on Teams, okay, for you to submit your flowchart to. Please make sure you submit your flowchart. Okay. I'll be around during the session to help you out, to answer any questions and to make sure that people are clear. Okay. Thank you for watching, and please do let me know if there's any questions or any problems.